One of the skills that comes up later, especially in calculus, is recognizing a composition of functions. Now, when we're talking about a composition of functions, which is y equals f of g of x, one thing in a language we often say is we say that g of x is inside of f of x. We do g of x first, and then we do f of x. But what's happening when those two functions get combined is we'll often say, well, that means that one function is inside of another function. And if we can recognize which function is inside of the other function, it's easy to determine two functions, f and g, so that they have a composition of functions. For example, in A, y equals x minus 2 cubed. Can you see that an x minus 2 is inside of something being cubed? So we would say that our inside function is x minus 2. And what's happening to that inside function? It's getting cubed. So our outside function cubes. Our inside function is x minus 2. And then if you plugged an x minus 2 into f of x, it would get cubed. For B, our inside function is 3 plus x. What's happening to our inside function? It's getting square rooted. So our outside function square roots. And if you think about, with any of these, you could do a check. If I did f of g of x, g of x is 3 plus x, and then f of x, whatever you plug into f of x gets square rooted. And sure enough, it matches up. Yes? You could always make your outside function equal to x. Or your inside would work too. And then have the second function identical, which is a cheating way. In this situation, not a cheating way, it's right. But in this situation, for looking forwards to calculus, you have to be able to recognize when one function is inside of another. That's why it's important to look here and say, can I see something inside of something else? But yes, we could. So what Nico's saying, what happens if I made my inside function x? Then what gets plugged into f of x? Just the x. And I could make f of x then exactly what I want it to be in the end. And that would work as well. So as a result, we don't get questions like number 4 on the exam, because you could just really make a simple case. Plus, there's also an infinite amount of right answers that all work out to be the same. All right, questions for practice? 3, 7, and 9.